Okay, good morning students. So we were discussing basically BOD, right? And I told you in the next class we'll be solving few numericals on BOD. So as we had discussed in the previous class, BOD it is equal to the DO consumed. I told you that it's a process which takes at least 5 days at 20 degree centigrade or 3 days 27 degree centigrade incubation. The initial DO has to be determined, and after 3 days at 27 degree centigrade it has to be incubated, or maybe for 5 days at 20 degree centigrade it has to be incubated, it has to be kept in an incubator, and then final DO level is determined, right? So what is basically the way to determine BOD? After suppose 5 day 20 degree centigrade incubation, it is equal to DO consumed multiplied with the dilution factor or the dilution ratio. I told you that initially the DO has to be determined. Suppose initial DO is referred to as DI. Okay, and you know initial DO will be higher with respect to the DO left after 5 days. Why? Because the oxygen will be utilized. The microorganisms will utilize the oxygen for the decomposition of the organic matter, right? So initial DO at day 1, okay, it is DI, and after 5 days 20 degree centigrade incubation, final DO is suppose D small f. Then what is the DO consumed? What will be the DO consumed? Initial DO, which is higher with respect to the 5 day DO left, so DI minus DF, right? Now with that is the dilution factor. What is the dilution factor? Dilution factor is equal to volume of diluted sample divided by volume of undiluted sewage sample. One example is given. Suppose 1 milliliter of sewage is diluted up to 100 ml. ठीक है ना? There is a 1 milliliter of sewage sample and it has been diluted to make a volume of 100 ml. Then what will be the dilution ratio or dilution factor? It will be volume of diluted sample divided by volume of undiluted. So what is the volume of diluted sample? The sample has been diluted to 100 ml, right? The sample has been diluted to 100 ml. And what was the initial volume? What was the volume of undiluted sample? 1 ml. So what is the dilution ratio? Volume of diluted sample divided by volume of undiluted sewage, that is 100 by 1. Dilution ratio, dilution factor will be 100. So what will be the DO consumed, or I beg your pardon, what will be the total BOD? The total BOD will be DO consumed, which is this DI minus DF multiplied with the dilution factor, which is 100. Is there any doubt? It's okay now? Then the oxygen demand for decomposition of organic matter can be classified into two parts. You know, the BOD can be broadly classified into two parts or two stages. Rather, we should say there are two stages of BOD. First is the carbonaceous demand, or which is referred to as first stage BOD, and the second is the nitrogenous demand, or the second stage BOD. What is this? Basically, BOD is a ongoing process. Okay, so first 20 days, suppose there is a sewage sample. Okay, we are going to determine the BOD, or if we don't determine even, but in the wastewater sample, in the sewage sample, this process takes place for first 20 days. पहला 20 दिन, first 20 days is referred to as carbonaceous oxygen demand. That means the first 20 days or so is required to oxidize the carbon present in the sewage sample, right? For the first 20 days, BOD is referred to as carbonaceous oxygen demand. That means The first stage, oxygen is utilized to oxidize the carbon content of the BOD. Okay, so first 20 days or so is basically involved in carbonaceous oxygen demand, and after that, after end of 20 days, okay, next is the nitrogenous oxygen demand or the second stage. In that stage, basically, the nitrogen content, it may be ammonia, it may be nitrite, nitrate, they are oxidized. Okay, and that oxygen demand is referred to as nitrogenous oxygen demand, and that is the second stage of BOD. Okay, so we will solve few numericals on BOD first, and let me tell you, those numericals are very important for your semestral exam as well as for any public exam that you appear. You will definitely get questions from BOD. So this is the question. If 2.5 milliliter of raw sewage has been diluted to 250 ml, okay, and the dissolved oxygen concentration of the diluted sample at the beginning of the BOD test was 8 mg per liter and 5 mg per liter after 5-day incubation at 20 degrees centigrade. So you are required to find out what is the BOD of raw sewage. Okay, what are the contents of the question, or what are the inputs that have been provided in the question? We have been told that 2.5 ml is the sewage volume. Initial volume कितना है sewage का? 2.5 ml, right? It has been diluted to 250 ml. ठीक है ना? Dilution करके कितना इसको increase कर दिया गया. The 2.5 ml sample has been diluted to 250 ml, right? Initial dissolved oxygen level has been told here. Initial DO. Initial DO is 8 mg per liter. And you know DO depletes, DO level decreases, right? So after 5 days at 20 degrees centigrade incubation, the final DO is 5 mg per liter, right? So initial DO DI is 8 mg per liter. Final DO, that is DF, is 5 mg per liter. The dilution has been told 2.5 ml sample has been diluted to 250 ml. So what will be the dilution factor? Diluted sample by volume of undiluted sewage. So diluted sample is 250 divided by the volume of undiluted sewage, that is 2.5. So 250 by 2.5, right? So just to tell me by calculation what is the value of BOD after 5 days. 300. Other students? 300. All of you agree with this? It's 300. What is the initial DO? 8 mg per liter, right? What is the final DO? 5 mg per liter. This is at 5 days 20 degrees centigrade. I told you students that storing the BOD sample in an incubator, in the environment lab you have seen the incubator, the fridge size green color boxes, right? And it is mentioned BOD incubator. Those are the incubators. So either the sample has to be stored for 5 days at a set temperature of 20 degrees centigrade, or else we can also do, we can store it for 3 days at 27 डिग्री सेंटीग्रेड. ये याद रहे, या तो 5 दिन स्टोर करना है इंक्यूबेटर में सैंपल को 20 डिग्री सेंटीग्रेड में, तब भी बीओडी डिटरमाइन होगा. Otherwise we can store for 3 days at 27 degree centigrade, which is the normal room temperature in our country, right? So final DO is given 8 mg per liter. So what is the DO consumed? How much dissolved oxygen has decreased? 8 minus 5, right? That is 3 mg per liter. This is the amount of oxygen which is consumed. Initially 8 था, उसके बाद 5 दिन के बाद 5 रहे. That is 3 mg per liter has been consumed. What is the dilution factor? It is equal to volume of diluted sample, which is 250 ml, divided by volume of raw sewage or undiluted sewage sample. That was 2.5 ml. Since it's a ratio of ml and ml, so unitless. So 250 divided by 2.5, it is 100. So that is why BOD after 5 days, we write it as BOD and in suffix we write 5. So BOD 5 is equal to the DO consumed, which is 3, multiplied with the dilution factor, which is 100. So it is 300 mg per liter. Please do remember the unit of BOD is mg per liter. The unit of DO is mg per liter. The unit of BOD is same as the unit of DO, that is mg per liter. It's clear? The same has been shown. Now, very important segment of BOD. You have noted? I'm erasing it, okay? So we have come to very important segment of BOD. If capital L is the organic matter present at the start of BOD reaction, okay, and capital Y T is the total amount of organic matter oxidized in T days, and Kd is the deoxygenation constant, then BOD after T days is given by the expression this, okay. Yt is equal to L into 1 minus 10 raised to the power minus Kd into T. Okay. What is this L? L is total organic matter. Total organic matter at the beginning. I have told you students, biochemical oxygen demand, BOD, is the amount of oxygen required to oxidize the organic matter. है ना, simple. So at the start of the reaction, suppose day 1 then, what is the value of organic matter? That is capital L, right? Organic matter is capital L. Is it clear or not? The total organic matter before oxidation. Oxidation start नहीं हुआ, कोई reaction start नहीं हुआ. Initially the organic matter is capital L, right? Now suppose after 5 days, okay, after 5 days we have to find out the BOD. So what is this Yt? Yt is the BOD at the end of suppose 5 days. This T is a variable, ठीक है ना? If we are required to find out 5 day BOD, we will write Y5. ठीक? If we are required to find out what is the BOD after 8 days, okay, so Y8. ठीक है ना? Similarly here also Kd into T, okay, C suffix Kd into T. So if we are required to find out BOD after 5 days, Y5, here also it will be 5. ठीक है ना? It's clear? So Yt is the organic matter or BOD after T days. Yt. Okay, that is written. Now Kd is the deoxygenation constant. What is this? Kd. K and suffix D. It is the deoxygenation constant. The oxygen is decreasing. Okay, so it is deoxygenation process. The oxygen level is decreasing, right? You know D and D. D means decreasing, and re means supplying that or adding addition of that, right? So deoxygenation constant, that means what is the rate of decreasing of or depletion of oxygen. What is the rate of decreasing or depletion of oxygen? Okay, that is referred to as Kd. So Kd is the deoxygenation constant. So BOD after T days, okay, or organic matter left after T days, it is given by this expression L into 1 minus 10 raised to the minus Kd into T. Okay, one more very important thing to be noted over here is that Kd is equal to 0.434 into K. So one more constant has come. Kd is equal to 0.434 into K. Now what is this K? K is the rate constant. Okay, in any question, if you are given the rate constant, okay, you have to multiply 0.434 with the rate constant to find out the value of deoxygenation constant. ठीक है ना? In the question, if rate constant is given, suppose rate constant 0.23 is given. How will you find out the deoxygenation constant? By multiplying this 0.23 with 0.434. These things you will have to remember. So it is written now Kd is equal to 0.434 into K, where K is the rate constant for oxidation of organic matter. The oxidation of organic matter, because organic matter will be oxidized and the oxygen will be consumed. ठीक है ना? Microorganisms will oxidize the organic matter with the help of oxygen available. Okay, so K is the rate constant, Kd is the deoxygenation constant or deoxygenation rate constant. Now, one very important thing to be noted over here is that this formula, okay, this formula is suitable at 20 degree centigrade. ठीक है ना? This formula is suitable at 20 degree centigrade. Now, if you are required to find out, suppose in the question, find out 8 days. Find out 8 days 15 degree centigrade BOD. Okay. Or you are required to find out 10 days. If you are required to find out the 10 days, we can put the formula y10 is equals to L, if it is there, 1 minus 10 minus Kd into T. Here it will be 10. If it is 8, here it will be 8. But the formula is valid for 20 degree centigrade. There is a twist. Okay. So if it is not 20 degree, if the question is that you find out either at 15 degree centigrade or you are required to find out suppose at 27 degree centigrade, okay, then we have to find out first what is the 20 degree centigrade deoxygenation rate constant. Okay, for Kd T degrees, suppose we are required to find out BOD for 8 days or BOD for 10 days, okay, at 27 degree centigrade. So first we will have to find out what will be the deoxygenation constant at 27 degree centigrade. Okay, we have to find out first Kd at 27 degree centigrade. Clear? Because we know the formula was valid for 20 degree centigrade. Okay, now we are required to find out the BOD for suppose 10 days at 27 degree centigrade. So first we will have to find out what is the Kd at 27 degree centigrade. It is given by this Kd at 20 degree centigrade multiplied by 1.047 into T minus 20. So Kd at 20 degree centigrade, whatever value given in the question, okay, multiply it with 1.047 and T raised to the power T minus 20. What is T? 27. So 27 minus 20. Is it clear? This formula holds good for 20 degree centigrade. If we are required to find out BOD for 8 days, 10 days, 15 days, whatsoever at a different temperature. So first we will have to find out what is the deoxygenation rate constant at that temperature. Okay. If it is 27 degrees centigrade, then we have to find out what is the deoxidation rate constant at 27 degrees centigrade. That is why KD20, which will be given in the question, okay, that will have to multiplied with 1.047 raised to the power capital T. It is here 27 minus 20. Suppose it is 15 degrees centigrade. If you are required to find out at 15 degrees centigrade, so what will be the formula? KD15, okay, is equals to KD20 multiplied by 1.047 to the power 15 minus 20. Okay, that means minus 5 raised to the power minus 5. Is it clear? So how many formulas you will have to remember? You will have to remember basically the previous one that we discussed, DO consume, that is initial DO minus final DO into dilution factor. BOD का ये formula. Second and most important है in this particular slide that capital L is the organic matter at the beginning, okay, when the process has not started, and YT is the organic matter after T number of days. It is given by the expression L into 1 minus 10 raised to the power minus capital KD into T, where capital KD is the deoxidation rate constant at 20 degrees centigrade, okay, multiplied by the number of days T. So if we are required to find out the KD or BOD at a different temperature, we'll have to definitely work it out. Okay, we have to find out first what is the deoxidation rate constant at that particular temperature. So you'll have to remember this formula and this formula. And one more thing is this KD will be equal to 0.434 into K. If rate constant is given, if the rate constant of deoxidation is given, KD 20 will be 0.434 into that rate constant. It's clear? So we will discuss one numerical, important numerical. This is the question. The BOD 5 of a wastewater sample or wastewater is 150 mg per liter. Okay, at 20 degrees centigrade. The K value is known to be 0. Please see here K value, that is the rate constant. The K value is known to be 0.23 per day. Okay, what will be BOD 8? What will be BOD 8 if the test is run at 15 degrees centigrade? So what is provided in the question? We are provided with BOD of a wastewater is 150 mg per liter. Okay, BOD 5 has been told. 5-day BOD is given, right? That is basically 150 mg per liter at 20 degrees centigrade. 5-day incubation के बाद the BOD of the sample is 150 mg per liter. It is given in the question. The K value, rate constant, is given as 0.23 per day. Okay, the rate constant K is given, right? What is required? You are required to find out what will be BOD 8, means after 8 days what will be the BOD, and provided the temperature is 15 degrees centigrade, 15, right? So what things you have to find out? You have to find out basically first capital L. पहले क्या find out करना होगा हमें? What is the capital L? Has it been given in the question? Initial organic matter is not given in the question. First we will have to find out capital L, right? Then we will have to find out what is the deoxidation rate constant at 15 degrees centigrade, KD 15, right? And then we will be able to find out what is Y 8, because BOD 8 is required. After 8 days, what will be the BOD that is required? So everyone try. If there is any doubt or query, you can ask. And you will definitely get this kind of question in your semester as well as in any public exam that you face. Junior engineer, PSC junior engineer, KMC engineer, and all that. You will get this kind of question. Not this much simple. It will be more complex. It will be a difficult type of question, but Underlying theory will be this only. So try as many questions as you can on BOD. It's very very important. Environment में सबसे important topic हो गया ये BOD for any kind of examination that you face in future. Okay. So what is given in the question? BOD 5 is given. BOD 5. What is the value? 150 mg per liter. Okay. So the formula YT is equals to capital L into 1 minus 10 raised to the power minus KD into T. This is the formula, right? So Y5 is there, 150. ठीक है ना? What else is given in the question? The rate constant has been told. Capital K is given 0.23, right? So can we find out KD? We can find out 0.434, 0.434 into this K, right? So tell me what is the value of capital L? Means we know this value, we know this KD, we know this T, 5, right? So tell me what is the value of capital L? What was the organic matter at the beginning? Yes, 21, 2.34. Is it 2.34? Is that possible that 5 days is 150 and initially it is 2 point, means it has increased? 220 you are telling. 2258. This. It's coming like that. Those of you who are solving, it's coming like that. 220.58. Is it correct? Just what you will have to do, you will have to put the value YT is 150, okay, is equals to capital L, which has to be obtained, into 1 minus 10 raised to the power minus KD into T. This KD is basically 0.434 into 0.23, ठीक है ना? And what is this T? T is 5, 5. So tell me just what is the value of, some of the students have found this value, okay, so it's correct or not? That is verified. You are getting 212 point. Okay, okay. You are telling the final answer. Okay, let others try. So organic matter at the beginning was maybe 220 like that. Okay, 220.5. It's correct now? Or is there any other answer that you are getting for capital L? It's correct. Okay. Then now you are required to find out Y8, right? You are required to find out BOD at 8th day. Okay, but what is the condition? You are required to find it out at 15 degrees centigrade. That means you will have to first find out what is KD 15, which will be just we discussed KD at 20 degrees centigrade, which you have obtained here, multiplied by, it was 1.047, no? 1.047 raised to the power capital T minus 20. Capital T here is, students, 15 degrees centigrade. That means 15 minus 20. That is minus 5, right? So you find out what is the value of KD at 15. 0.18. So Kaushik is telling 0.KD15 0.18. What about other students? You are also getting the same value. It's correct, 0.18. It's correct, right? So when KD15 we have got, now what is required? We have to find out basically Y8. Y8. We know capital L, that is 220.58, 220.58. Yes. 1 minus 10 raised to the power minus KD, which is this value that you are getting, which is perhaps 0.18, right? 10 raised to the power minus 0.18 into T, which is 8. So just to find this, solve this and you will get the value. Yeah. Okay, in the solution part, their answer was this. Your answer was around 220.58 that you have got, right? So this will be accepted, right? And now find out the value of Y8. What is the value? 212.63. Why? Okay, let us see. What is the value? They are getting the value 168.2. So where is the coordination gap where you have made mistake? This value would have been 0.079 instead of 0.18. 0.07, 0.07, that is also okay, or 0.08 is also okay. So you had told 0.08. Okay, I heard it wrong. Okay, anyhow, so just you put the values, KD15, you put the value and you will be getting Y8. Is it clear? Is there any doubt, any query? So if you are given question like this, or maybe if it is a complicated question but with the same basic theory, I think you will be able to solve it, right? Now very quickly we will discuss one topic, relative stability, and that will be the end of the class. Relative stability. It is also very important. It's also a very important topic, relative stability. So the term relative stability, students please carefully listen. What is relative stability? Relative stability is the amount of oxygen available. What I am telling, the amount of oxygen available in the organic or in the wastewater sample. Okay, the amount of oxygen available in the wastewater sample, okay, with the amount of oxygen that was actually required to oxidize. ठीक है ना? relative stability. Relative stability means it's also a with respect to something it is finding out. So it is basically what is the amount of oxygen available in the sewage sample, in the wastewater sample, with respect to what is the total amount of oxygen required. Suppose there are 10 students or there are 10 persons, okay, and there are only 8 jobs available. There are 10 persons and there are 8 jobs available. So what is the lagging? That is 2. If there would have been 10 jobs for 10 persons, they would have been satisfied, right? Similar to that, what is the oxygen available, right? And what is the total oxygen required to oxidize the organic matter? That basically is the relative stability. The term relative stability of a treated sewage effluent may be defined as the ratio of oxygen available in the effluent. Effluent means wastewater. Effluent is referred to as wastewater. Okay. So the amount of oxygen available in the effluent, okay, the oxygen may be available directly in the form of oxygen or in the form of nitrite or nitrate, right? If the oxygen is available in the form of nitrate or nitrite, that is also the oxygen only, okay. So the amount of oxygen available, okay, in the effluent to the ratio of total oxygen required to satisfy the first stage of BOD. रिलेटिव स्टेबिलिटी का सिंपल मतलब है स्टूडेंट्स, व्हाट इज द टोटल क्वांटिटी ऑफ ऑक्सीजन अवेलेबल एंड रेशियो ऑफ टू द total quantity of oxygen that was required for oxygenation process or oxidation process or decomposition of organic matter. कितना अवेलेबल है और कितना का जरूरत था, उस रेशियो को हम बोलते हैं रिलेटिव स्टेबिलिटी. इफ मोर ऑक्सीजन इज अवेलेबल, मोर मीन्स suppose the total quantity of oxygen required and the available is same, then relative stability will be 1. If the ratio of available oxygen and total quantity required is same, then the relative stability will be 1. And if the available oxygen is less and with respect to that more oxygen was required, so the value will be in that case less than 1. So the value of relative stability will be either 1 or less than 1. Can it be more than 1? If more oxygen is available, okay, with respect to the total amount of oxygen required for oxidation, that is a rare chance. In waste water at least rare chance. ऐसा हो नहीं सकता कि एक waste water sample है, एक sewage sample है, enough oxygen, then what was the requirement, more than that oxygen is available. That is not possible in wastewater. That will be possible in fresh water, okay, river water, streams, lakes, ponds, all the surface water bodies, or in drinking water. You know, in drinking water also there are minerals, there are TDS, okay. So basically in drinking water, in potable water sources, in consumable water and in surface water bodies, this possibility is there that amount of oxygen available is more than that was required for oxidation, okay. But in wastewater sample, in sewage sample, it's not possible. So what is the formula for finding out the relative stability? The formula is capital, the relative stability is referred to as capital S, okay. It is equal to 100 multiplied with 1 minus 0.794 raised to the power T20, okay. Or there is another formula, 100 multiplied with 1 minus 0.630 raised to the power T37. What is this T20 or T37? These are basically time in days. If it is 20 days, which is the first stage of BOD, we have discussed that the first stage of BOD extends up to 20 days, and beyond that is the second stage, that is the nitrogenous demand, okay. So T20 is the number of days, okay, and T37 are also the number of days for a sewage sample to decolorize a standard volume of methylene blue solution when incubated at 20 degrees centigrade at 37 degrees centigrade. So basically T20, T37, they indicate the temperature for the number of days, okay, the sewage sample has been kept, and a Seaway sample will decolorize a standard volume of methylene blue solution. Okay. So relative stability simply आप समझ जाइए कि amount of oxygen available to the ratio of total oxygen required, right? So in the next class we will solve one numerical based on relative stability, and also there is a term called population equivalent. Okay, one more term is called population equivalent that we will discuss, and then we will uh, move to the next part of this particular module, that is biological or bacteriological characteristics, which is the last segment of this module. So hopefully tomorrow we will finish the module. Okay. So that's all for today. Okay, we'll meet in the next class. Thank you all.